Have you ever wondered how complex systems are designed and analyzed? How do we translate an idea into a working software application? Let's start with the basics. Object-Oriented Analysis and Design, or OOAD, is a method used to analyze, design, and implement a system. It's all about breaking down a system into manageable, interacting objects. Each object represents some real-world entity with responsibilities, behaviors, and states. This approach is incredibly powerful, as it allows us to model complex systems in a way that closely mirrors the real world. Now you might be wondering, how do we visually represent these objects and their interactions? Enter the Unified Modeling Language, or UML. UML is a standardized way to visualize the architecture of a system. It's like the blueprints of a building, helping us understand the structure, behavior, and various aspects of a system. The beauty of UML is that it provides a common language for everyone involved in the development process. It doesn't matter if you're a business analyst, a software architect, a developer, or a tester, UML diagrams will give you a clear picture of the system. UML encompasses a variety of diagram types, each designed to address a different perspective of the system's architecture and behavior. These can be broadly classified into two categories: structural diagrams and behavioral diagrams. Structural diagrams show the static structure of the system, while behavioral diagrams illustrate the dynamic behavior. Structural diagrams include class diagrams, object diagrams, package diagrams, component diagrams, composite structure diagrams, and deployment diagrams. Each serves a different purpose in visualizing the structure of the system. Behavioral diagrams, on the other hand, include use case diagrams, sequence diagrams, activity diagrams, state diagrams, communication diagrams, interaction overview diagrams, and timing diagrams. These help us visualize the behavior and interactions of the system's components. UML is not just about creating pretty diagrams, though. When used effectively in OOAD, it helps bridge the gap between concept and implementation, providing a clear visual representation of classes, relationships, processes, and behaviors. By the end of this video, you'll have a solid understanding of the different types of UML diagrams and their role in OOAD. Structural diagrams are the backbone of any system, representing its static structure. We begin with class diagrams, the workhorse of UML, which lay out the static structure of the system. They showcase classes, their attributes and operations, along with the relationships among objects. In object-oriented analysis and design, these diagrams are key, providing the groundwork for the system's code structure. Moving on, we have object diagrams, which in essence are snapshots of class diagrams. They capture a specific moment in the system's life, illustrating how objects interact and their state at that time. They're like a freeze frame, offering a unique perspective on the system's dynamics. Package diagrams come next. These diagrams are your best friend when dealing with large-scale systems. They organize elements into groups and reveal the dependencies among these groups. It's like having a bird's-eye view of the system's landscape, helping you understand the overall structure and dependencies. Next in line are component diagrams. These diagrams focus on the software components and their dependencies. They're useful for illustrating the physical components in system builds, including source code, binaries, libraries, and so on. They're like a blueprint guiding the construction of the system. Then we have composite structure diagrams. These diagrams delve into the internal structure of classes and the interactions at runtime. Especially useful for complex structured classes, they provide a deep dive into the system's inner workings. And finally, we have deployment diagrams. These diagrams map out the physical deployment of artifacts on nodes. They model the hardware topology of a system and how software is distributed across nodes. They're like a roadmap, detailing where everything goes in the final system deployment. Each of these diagrams serves a unique purpose, shedding light on different aspects of the system structure. Class diagrams lay the foundation, object diagrams provide snapshots, package diagrams offer a bird's-eye view, component diagrams act as blueprints, composite structure diagrams give a deep dive, and deployment diagrams map out the final layout. Understanding these diagrams and their roles is fundamental to effective object-oriented analysis and design. They offer a visual guide, simplifying complex structures and interactions. They help bridge the gap between conceptual models and actual software development, making the process more manageable and efficient. Remember, these diagrams are not standalone. They work together, each contributing to a comprehensive understanding of the system's structure. When used effectively, they can significantly enhance the system's design and implementation process, making it easier to foresee potential challenges and address them proactively. These diagrams play a crucial role in defining the system's architecture and how its components interact. So, as we venture further into the world of UML and OAD, let's not forget the importance of these structural diagrams. They form the backbone of our system, providing the structure upon which everything else is built. Now, let's delve into the dynamic aspect of the system, the behavioral diagrams. These diagrams are all about capturing how the system behaves over time and how different components interact with one another. First up, let's talk about use case diagrams. These diagrams are pivotal in the early stages of development. They illustrate the functionality provided by the system in terms of actors and their goals, and any dependencies between those use cases. These diagrams are crucial during requirements gathering and analysis. Next, we have sequence diagrams. These diagrams show how objects communicate with respect to the sequence of messages. They are particularly useful for mapping out object interactions and understanding the flow of operations for specific scenarios. Moving on, we come to activity diagrams. These diagrams represent workflows from a start point to a terminal point. They show the sequence of activities and decisions, making them helpful for both high-level process modeling and detailed process modeling. Then we have state diagrams, also known as state machine diagrams. These diagrams model the states and behaviors of a system or a component using states, transitions, and events. They are great for visualizing how an object changes its state in response to events. Communication diagrams are next on our list. These diagrams focus on the interaction between objects, but with an emphasis on the relationships and groupings of objects. They are great for visualizing the organization and relationships within a system. Interaction overview. Diagrams are a blend of activity and sequence diagrams. They map out the control flow among various interaction diagrams. This type of diagram provides a high-level view of an interaction, showing the sequence in which interactions occur. Last but not least, we have timing diagrams. These diagrams are specifically useful in real-time systems. They show behavior in terms of timing constraints, giving you a clear picture of when interactions occur in relation to each other. Each of these behavioral diagrams plays a distinct role in object-oriented analysis and design. They allow us to capture the dynamic nature of a system, showing not just what the system does, but how and when it does it. By using these diagrams effectively, we can ensure that our system behaves as expected, meeting all of the necessary requirements and delivering a high-quality user experience. Remember, the real power of UML lies in its ability to provide clear visual representations of complex systems. By using these diagrams effectively, we can bridge the gap between concept and implementation, ensuring that we deliver a system that meets the needs of its users and stakeholders. In conclusion, understanding and implementing behavioral diagrams in UML are crucial components in the process of object-oriented analysis and design. These diagrams provide a clear picture of the system's behavior over time and how different components interact with each other. Now that we have a good understanding of the different UML diagrams, how do we use them in OOAD? In the world of object-oriented analysis and design, the analysis phase is critical in understanding the system's requirements and how they should be implemented. This is where UML diagrams come in handy, serving as a visual guide that helps bridge the gap between concept and reality. Let's start with use case diagrams. These diagrams are instrumental in capturing functional requirements and user interactions. They provide a high-level view of what the system should do from the perspective of the end user. By clearly defining the roles of each actor and their interactions with the system, use case diagrams help in identifying the necessary classes and methods, laying the groundwork for the design phase. But it doesn't stop there. Activity and state diagrams play an equally important role in detailing process flows and state changes. Activity diagrams, with their intuitive flowchart-like structure, outline the sequence of activities and decisions in a system's operation. They give us a clear picture of the workflow and help identify potential bottlenecks or areas that need optimization. On the other hand, state diagrams, also known as state machine diagrams, provide insights into how the state of a system or a component changes over time due to events and conditions. They are especially useful when dealing with complex systems, where the behavior depends on the current state and the history of past states. In essence, the analysis phase in OAD is all about understanding the system's functional and non-functional requirements, its behavior, and how it interacts with its environment. UML diagrams, with their standardized notation and comprehensive view, serve as an invaluable tool in this process. They help in visualizing, specifying, constructing, and documenting the artifacts of a software system. And there you have it, a comprehensive overview of UML diagrams and their role in OOAD. Remember, the key to effective system design and analysis lies in choosing the right UML diagrams for your specific needs.